All right, so chapter 18. As I told you with chapter 17, we kind of have that here's the microanatomy, here's the microphysiology part of the chapter or part of the system. So we now know how the hormones work, what classifications we have, what they bind to. Now let's talk about the actual glands themselves and what they release and how they work. Okay, so outline of the chapter. The endocrine system's regulation of the body. We're going to talk about, like I said, the anatomy of each gland and where it's located at, because we have, as you can see over here, quite a few of them. Hormones that are secreted by the gland, because some glands do secrete multiple hormones, especially when we're talking pituitary. The target tissues and their responses to that hormone, the regulation of the secretion of that hormone. Remember, we talked about that last chapter. We said that there's humoral regulation of hormone secretion, things like glucose causing the secretion of a hormone. We talked about the nervous system controlling the release of a hormone, and we also talked about hormones controlling the release of other hormones. And then the consequences and causes of hyper or hyposecretion of some of the hormones. Okay, so functions. We have 8 functions that we're going to talk about when it comes to the endocrine system. Metabolism and tissue maturation, ion regulation, water balance, immune system regulation, heart rate and blood pressure regulation, control of blood glucose levels and other nutrients, and control of reproductive functions, as well as uterine contractions and milk release. So, metabolism and tissue maturation. Just as an example for metabolism and tissue maturation, thyroid hormone actually influences how fast your metabolism is. When you have an abundance of it, your metabolism is actually fairly fast. When you don't, your metabolism slows down. It also influences the maturation of tissues. You've got some hormones that influence the maturation of immune cells, and you've got some hormones that, okay, sorry, I've got to sneeze. Sorry, influence the maturation of things in the nervous system. Second, ion regulation. So ions, if you'll remember, are atoms that have charge. pH deals with the hydrogen atom. So, or ion, I'm sorry. So that is ion regulation. Sodium, potassium, calcium concentrations in the blood, all of these are going to be ions when they're balanced. Water balance, controlling the amount of solute in your blood, basically the solute concentration. Don't forget that this just means concentration. So solute concentration, how salty is your blood? I know that sounds really funny, but how salty is your blood? Do we need more water? Do we need to get rid of some water? That's water balance. Immune system regulation, controlling the production of immune cells. Again, we've got some immune cells that actually have to get chemically activated. So yeah, that's endocrine system. Heart rate and blood pressure regulation. It helps to prepare the body for physical activity. We kind of already touched on this when we talked about epinephrine and norepinephrine. Now, I know that we talked about those as part of our autonomic nervous system, but we have the adrenal gland. The adrenal gland also releases those chemicals as a flood of those chemicals into your system, which actually does the same thing. Hang on, I forgot to mute my other computer. Anyway, it helps to get the body prepared for the whole fight or flight thing. Okay, control of blood glucose and other nutrients in your blood. So we kind of touched on this when we talked about insulin. Insulin is one of those things that controls our blood glucose levels. So it's a nutrient that is in our blood. Control of reproductive functions. Not only are we talking about the development of our reproductive system, getting surges of testosterone to make the testes viable, basically meaning that you can use them to fertilize an egg, and getting the uterus and the breasts ready for holding and caring for a baby after birth, but the functions of those systems are also controlled by those same hormones. If you don't have those hormones in enough abundance, then you can't do those things. Even if you are a grown man, if your testosterone is too low, you can't make viable sperm. You don't have enough sperm to actually fertilize an egg. If you are a woman and your progesterone and estrogen levels drop too low, you're not going to be able to prep the uterus for implantation, and you're not going to be able to hold a baby to term. Uterine contractions and milk release. During childbirth, we release a hormone called oxytocin. If you think back to AP1, when we were talking about the positive feedback loop, we talked about oxytocin getting released from the brain and going down and causing uterine contraction. In addition to that, it actually causes milk letdown in the breast, basically meaning that you're in labor, there's going to be a baby soon, so your breasts actually get ready for feeding that baby. After birth, you also have prolactin, another hormone that basically gets that milk production going. And when the baby latches on, your brain again releases that oxytocin to cause the milk letdown. So, very diverse system when it comes to its functions. So let's talk pituitary gland and hypothalamus. These two are always talked about together because they are very, very interwoven as far as function goes. So the hypothalamus is actually within the brain. So both of these things are up here in the brain, and that's just this blown up. So the hypothalamus is this area right here. Okay, pituitary is this thing down here. If you think back to the parts of the skull, that sella turcica that looked like a saddle the little monito could sit in, that actually is where your pituitary sits. Okay, so the hypothalamus is kind of your major integration site between your nervous system and your endocrine system. Can't take me anywhere and be proud. So this is where they major league interact. The hypothalamus regulates secretions also of the posterior pituitary. So in this picture, it's very simple to see that the back from the front of that pituitary are very different. Okay. Hormones, sensory information that enters your central nervous system, emotions, all of these things influence the activity of that hypothalamus. This is one of the reasons why when we discuss the hypothalamus in AP1, we talk about it being part of our emotional brain. In the pituitary gland, you've got basically 9 major hormones that are regulating numerous body functions and secretory activities of even other glands. With the posterior pituitary, so this dude back here, you're releasing neurohormones. Now remember, neurohormones are still hormones, but they're coming from neurons as opposed to endocrine tissue. So technically still hormones, it's just their origin that's different. Now, the anterior pituitary, you actually have 3 parts to that. You've got the pars tuberalis, the pars intermedia, and the pars distalis. Now, the hormones from there are actually not neurohormones. They're just regular hormones coming from endocrine tissue. So, let's talk about how our hypothalamus, which is up here, okay, influences the control of our pituitary gland. So we've got this little portal here. Remember, a portal is like a doorway or a gateway going from one place to another place. This portal is called the hypothalamo-hypophyseal portal system. I know, it's a great word, isn't it? I'm not going to say it again because bleh. But pretty much it's this little bundle of capillaries that extend from my hypothalamus up here down to my anterior pituitary here. So what that means is The hypothalamus can release neurohormones that travel along this little bundle of arteries to get down here to affect the cells that are within that anterior pituitary. So what does that ultimately mean? This. The hypothalamus controls the anterior pituitary. The anterior pituitary doesn't do anything unless the hypothalamus tells it to do it. So, concept map, which I call a family tree. Whoops. Here's the hypothalamus. Okay, so we've got the hypothalamus. Green means go. Okay, so if you see a green arrow, that means go. If you're experiencing low blood glucose, if you're experiencing stress, okay, that actually causes the release of growth hormone releasing hormone. I wonder what growth hormone releasing hormone causes the release of. So growth hormone releasing hormone actually goes to the anterior pituitary and it causes the release of growth hormone. Okay, so again, the hypothalamus controls the release of things from the anterior pituitary. Now, what caused it? Low blood glucose and stress, right? So if we have high blood glucose, the hypothalamus is going to release growth hormone inhibiting hormone. What do you think it's going to inhibit? The release of growth hormone. So that's why this is red. It means stop, just like red light, green light. Okay? So you've got the hypothalamus literally controlling the release of growth hormone. If you've got low blood glucose and stress, then you release growth hormone releasing hormone and growth hormone gets released. If, however, you've got high blood glucose, you don't need it, you're going to inhibit its release because you don't need it right then. Now, if you have low thyroid hormone levels, that's going to cause the hypothalamus to release thyrotropin releasing hormone. Okay. Now, if you see tropin at the end of something, and we don't use that name very much because of the fact that there are better names that kind of give you a hint as to what things do, know that those hormones always come from the anterior pituitary. Okay, so if you see tropin, that's what that means. So you've got low thyroid hormone, thyrotropin releasing hormone gets released. It again goes to the anterior pituitary and causes the release of thyroid stimulating hormone, which actually can be called thyrotropin. But thyroid stimulating hormone gives you an idea of what it does, so I like using that name better. Now, if I have high thyroid hormone levels, do I need more thyroid hormone? No. So it stops the release of thyrotropin releasing hormone, which means that none of this happens. If I don't release thyrotropin releasing hormone to basically stimulate the anterior pituitary to release thyroid stimulating hormone, then none of this happens. Okay, so you've got the kind of stop-go. Corticotropin releasing hormone. Again, tropin means that it's going to be going to my anterior pituitary. The anterior pituitary, when corticotropin releasing hormone, will release adrenocorticotropic hormone. Okay, just for the sake of me being a nerd, let's break this word down. Adrenocorticotropic. Now remember I said tropic means that it comes from the anterior pituitary, right? Cortico. There are two words that I've told you to know from the very beginning of A&P that always mean the same thing. Medulla means middle. Cortex means outside. Try that again, outside. So think of an M&M. The chocolate is the medulla, the candy is the cortex. So this is referring to the cortex. Now, adreno, the adrenal gland. It's the one that sits right above your kidney. So this is going to affect the adrenal gland's cortex, and it comes from the anterior pituitary. That's what that means, okay? If you learn prefixes and suffixes and learn the meanings of those prefixes and suffixes, you can cheat, okay? Which isn't a good thing for a professor to say, but it helps you out quite a bit. Gonadotropin releasing hormone. Okay, so this goes to the anterior pituitary and causes the release of LH and FSH. LH is called luteinizing hormone. FSH is follicle stimulating hormone. And both of these have to do with the gonads, gonadotropin. So the testes and the ovaries, okay? And then finally, we've got prolactin releasing hormone. Goes to the anterior pituitary, causes the release of prolactin, okay? So we've got basically 5 different influences on the anterior pituitary, and we've got 6 different hormones getting released by the hypothalamus that affect that anterior pituitary. Now, let's talk about the posterior pituitary. The neurohormones that are being released from the posterior pituitary aren't made by the posterior pituitary. The hormones are actually just kind of stored in the posterior pituitary. They're originally made by the hypothalamus. So if you look here, that's a horrible color to use. If you look here, see these neurons? You can see that they've got their cell bodies up here, but then their axons go all the way down to here in the posterior pituitary. You can see that in this figure. There we go. So you've got the cell body up here, the axons, and then the axon terminals exist in that posterior pituitary. Well, those neurohormones are actually being made by these neurons that are located in the hypothalamus up here, okay? They make the hormone, put it into a vesicle, a bubble, and they store it here in the axon terminals that sit or reside in the posterior pituitary. Technically, posterior pituitary is just a holding cell. It didn't make the hormones. It's not going to do anything specific with the hormones. Literally, the hypothalamus decides, sends a signal down this neuron to get them to release from here. So the action potentials to cause their release come from the hypothalamus. The hormones themselves that are neurohormones because they're coming from a neuron come from the hypothalamus itself. So technically, the posterior pituitary, for all intents and purposes, is just a holding cell. Now, so the hypothalamus and the posterior pituitary, it releases 2 different hormones. Antidiuretic hormone is one of them, and the other is oxytocin. And both of these, like I said, they're made in the hypothalamus. They just kind of get transported to the posterior pituitary. So they're made in one place, get stored in another place, and don't get released unless the hypothalamus gives it say so. So that is kind of how the hypothalamus influences both the anterior pituitary and the posterior pituitary. Now let's talk antidiuretic hormone. Its target is the kidney. Remember I said we're going to talk about targets and where does it go and what does it do, right? So antidiuretic hormone targets the kidney. What does it do? Antidiuretic hormone. What does a diuretic make you do? Diuretic makes you pee. So antidiuretic is going to basically increase water reabsorption. It's going to make you not pee so much. So basically what happens is you reabsorb water and then you create less urine. So you are going to the bathroom less. Now you might go, okay, when does that happen? When you get dehydrated, let's say you get a stomach bug and you're puking and puking and puking and you've got diarrhea really bad, your level of fluid in your body actually drops dramatically. You become dehydrated. Antidiuretic hormone is definitely going to get released at this point because one of the places that we lose the most fluid is when we're making urine. By releasing antidiuretic hormone, we're basically making sure that we don't lose what little fluid we have. So when the fluid gets to the kidneys, we basically tell the kidneys, hey, bring that back. Bring that, don't let that go, bring that back. So we're reabsorbing fluid that got put there. Now, oxytocin. Target-wise, we've got two targets here. We've got the uterus and we've got the mammary glands. So in a female, one, oxytocin causes increased uterine contraction and increased milk expulsion from the mammary glands. So I talked about this just a little bit earlier when I said when you go into labor, oxytocin gets released and causes the uterus to contract and at the same time goes to the breast and causes milk letdown so that milk is ready for the baby when it's born. We have a man-made version of this. If you have ever had the experience of having either your significant other or yourself being induced to labor, they will give you Pitocin. Pitocin is just man-made oxytocin, and it does the exact same thing. It causes the uterus to contract, which in turn causes you to have the baby, basically. Okay,